when we make big systems small, it allows us to but it allows us to have more space to make things, di ba? You've probably heard in your high school class or history of computing before, right? Meron silang mga ENIAC and stuff like that na parang yung mga computer nila dati is as large as a room. Now, you don't really see computers like that anymore because people have found na kapag ginawa mong microlab type, that is IC, yung computer mo, it is actually much better because smaller is better in these cases. Kapag mas maliit din, it gives us very low cost. So it allows you to make things very cheaply, and then you can also make the entire system in one go. Tapos also, I mean, very cool things happen in microscale. We will see that in the next slide, I think. So here, the example that we have right here is di ba? Merong LiDAR. LiDAR systems are usually but they're not usually anymore kaso they're somewhat big, no? And kasi meron kang source of light, tapos it bounces off something, tapos i-measure mo yung bumabalik na signal strength para malaman mo kung gaano kalayo yung object, and it allows you to 3D image things, right? And an example of making something smaller is to make this LiDAR system into just one IC chip. So kita mo dito sa kita niyo dito sa baba, right? Ginawa na nating isang chip yung LiDAR system. Tapos like this is a SPAD array, no? Tapos parang kailangan lang niya is basically isang photon, tapos mag-avalanche na siya if you remember that from your 41 or 131 is from your 131 class, magkakaroon ng avalanche breakdown, tapos madedetect na yung light. So magkakaroon ng like intense current changes from just a single photon. So that's the exciting part of making things smaller. So who are we in Microlab? So okay, here are the professors. So to me right now, the definition is mga PhD na at yun mga PhD-ing. So we have our beloved other professors here na they are currently not here. I don't think they're in the hall either. But the head of Microlab is Sir Louis. I don't think Sir Louis is here right now either. So that is unfortunate. Kaso if you have any problem about anything at all, analog circuits, actually digital circuits, low power design, you can ask Sir Louis. And actually he also handles like a lot of the like the server stuff, mga PDK, and yung mga conversations natin with the holders of our tools, ganun. Sir Louis actually handles a lot of those as well. So we can go to him if you need anything like that. And also Ma'am Tata is our god of digital systems. So hello Ma'am Tata.
Good morning.
Good morning po. So Ma'am Tata is very much the the person for low power digital designs. If I remember correctly, parang her work over the last decade, I guess, is on security. So security and security hardware, and also sub-threshold digital circuits. Tapos we have also Ma'am Tess. Hi Ma'am Tess.
Nasa chat.
So ayun po. Hi Ma'am Tess. So Ma'am Tess is So if you saw dun sa PubMat natin, there's this thing called microelectromechanical systems. So Ma'am Tess is basically the god of MEMS for us, and Ma'am Jean is also the other person for MEMS. So if you have any questions about that class, then you can ask them both. Tapos Sir Chard, okay? So Sir Chard couldn't make it today either. But if you have any questions about the CARE project or say wearables or biomedical devices, if that is your interest, you can actually ask Sir Chard about that. Last but not the least, si Sir Mark. So hello Sir Mark. Sir Mark even has his camera open.
Hello. Hi, good morning.
Morning, sir.
Morning.
So, sir, actually, would you like to mention, sir, kung ano yung photonics exactly? Kasi parang baka hindi clear sa kanila.
Okay. So, lately medyo yung mga activities na ginagawa ko related sa silicon photonics or optoelectronic circuits. So, yung example kanina ni Lawrence, magandang example yun yung isang ginagawa ng mga group under mga 198 or 199 next semester. So, nakita nyo merong laser at saka may mga photodiode. So, to drive those circuits and to read those circuits, meron kang mga laser driver circuits, tapos meron kang mga circuits for the photodiode. So, yun yung pinakita niya kanina na LiDAR system. So, kung yun yung interest nyo na tingnan, mga circuits that's related for optoelectronics, yun yung mainly titingnan ko ngayon as part of my recent activities. Pero, yun, like everybody else sa Microlab, iba-iba yung ginagawa namin or we are co-advising in each other's activities. So, merong analog, may RF. So, magkakasama kami doon doing those stuff din. So, yun lang. Tapos yun, optoelectronics mainly yung nalinya sa akin for this moment.
Okay, sige. Thank you, sir. So, I also saw na within the past decades no meron parang ibang parang stacks ng silicon substrates, parang mayroon silicon germanium, right sir, na parang tinignan ka within the past few years.
PhD work.
Sige. Thank you, sir. So after that, we don't have them here in the Philippines right now. Kaso currently taking his PhD in UC Berkeley is Sir Adel. I think what Sir Adel is working on right now is parang digital na online learning systems. And Sir Rico is currently Sir Rico and Sir Ryan actually are both currently in KU Leuven. Sir Ryan just recently left. Goodbye, Sir Rai. So Sir Rico was investigating on radiation circuits. So ano mangyayari kapag yung circuit mo tinamaan ng radiation? What kind of horrible or good things happen, right? Tapos si Sir Chito here, he is in KAIST in Korea, which is in Daejeon. Actually not sure what Sir Chito is doing right now yet. So you can ask him directly if you're interested in what Sir Chito is doing. Actually, Sir Louis is here na daw po. Sir Louis, are you able to open mic po?
Yes, hello. Finally, good morning, everyone. Sorry I'm late. It is nice to actually be back here at EEE for the longest time. So, but yeah, it's nice to see a lot of interest in the lab, and hopefully you guys enjoy working at the Microlab.
Thank you, sir. Okay, so those are the top professors. Tapos ito, nandito kami. So these are the other Microlab people. This is not all the Microlab people, by the way. Marami tayo. It's just that kami yung may teaching load right now. So si Sir Herlan, Sir Snap, Sir Fred, Ma'am Jean, Sir Miro, ako, si Allen, tapos si Ariel. So, you can tell kung sino yung kabatch ko. So, in terms of the number of students, so we currently have more than 20 graduate students, and actually we have also a very very large number of undergraduate affiliates right now. So that is right now, ha. So parang hindi siya yung including last year, and that is right now. So we're actually handling the 196 199 of this many people, and you will see what they're all working on later. It's actually a lot of projects. So, that just means that you're going to have a lot of possible variety if ever kung kasi ganito karami yung people that you can potentially work with. So, this is a picture of the graduate na room for Microlab. So, the room this is in the 4th floor, 404. 405. Tapos the undergraduates room is actually on the other side. Wala kaming actually makitang picture ng 403, which is the one for undergraduates. So here have this picture. It has people. Tapos kasi we were planning to have a picture of all this all the current undergrads here, kaso as you know, dahil sa pandemic, hindi wala tayo nun. 407 daw pala, sabi ni Sir Z. Hindi ko tinitingnan numbers eh. So, okay, brief history of Microlab. So, in 1987, the lab was created to pursue IC design specifically. This is a time na parang medyo mas malaki pa yung mga chips natin. See here, mga 100 micrometers pa siya. Actually, this is back in 2000 pala. So, over the years, we end up fabricating we end up fabricating a lot of chips, smaller and smaller over the years, and we acquire our current tools around 1999, and this is actually exciting, no? So you can see here that this is a chip that Microlab made back in 2001, di ba? And so I'm actually not sure about all the names here. I'm pretty sure some of the people here hindi ko kilala, but we know here si si Sir Louis LPA, Louis P. Alarcon, and Sir Richard E. Izon. So Sir Chard nandito din, and si Ma'am Tess is I think that's Ma'am Tess. Used to be G. So, it's actually this was one of my favorite parts of the orientation before nung pinakita nila tong chip na to, no? Kasi uy, cool. So, actually tapos now it's called 196 and 199, right? But 198 din nila to dati. It seems nakalagay. So, it's pretty cool to see. So, here are the here is a bird's eye view of the projects mentioned earlier, diba? So we went from very very large 2 micrometers up to very small nowadays, which is 65 nanometers, which is which is like extremely small compared to before. This is like you'll learn about it in 197U, kaso it just naturally gets smaller over time. Kaso our projects are really really distributed over analog and digital. So we make microcontrollers, we make RF circuits, so we make low noise amplifiers, OTAs, op amps, ganon. And sometimes it doesn't really change too much, right? We just put more emphasis into low voltage things. we just use new topologies that are discovered that are like a lot more efficient, but and also we're looking into like energy harvesting now and like very high frequency na communications, but still we look into analog and digital in this lab. So for our for our recent circuits, so most of these are from yung 65 nanometer technology ng ST back in 2010s, kasi nasa 2020s na tayo, no. So itong low voltage test circuits, apparently they never came back, kaso ginawa nila to to see like to just test the to just test the fabrication of ST65, but well, sadly it it never came back. So meron tayong low tolerant microprocessor din dito. Tapos meron tayong phase lock loop dito sa baba, which is I think dapat for for comms, if I remember correctly. So frequency synthesizer siya. Pina-follow nung phase lock loop natin yung frequency nung nung input. Tapos meron tayong mobile robotics controller dito, which is actually a project quite a big project back in 2012 for mobile robotics vision, which is here. So yung yung chip na yon was their goal was to design a microcontroller for to ano bang tawag, a microcontroller that is capable of controlling a robot um from visual data, which is actually a lot more of a significant thing back in 2012. Of course parang this was in the boom of computer vision as well, but very early on in the boom of computer vision as well, kasi parang it was in 2012, no. So this was a very important innovation. Back then it was a very important project to undergo. So for our current projects, no, we have CARE, which is headed by Sir Chard, along with some of the other departments in Triple E, if I remember correctly, parang in Triple E rather, in UP. So if I remember correctly, it also involves DCHE among others. So it's the Center for Air Research in Urban Environments. Tapos we also have CIDER, which involves most of the Microlab people right now. So it is the Center for Integrated Circuits and Devices Research. So in a little bit we'll have Sir Louis explain that. We also have had some previous projects. So Resense was we were trying to make wireless sensor swarms, like a lot of them, for monitoring the environment in the Philippines. Yung verse naman is the MEMS, is very much related to MEMS, Ma'am Tess and Ma'am Jean. So we harvest energy from the environment for the chips. So it's pretty much related to each other, no. Each thing will be useful to each other eventually. We also had SPICE, which was a collaboration between us and UPLB. So I've never seen it myself, kasi apparently in the basement of Triple E we have some plants that are being raised through hydroponics. So that is part of the was part of the SPICE project. So titingnan nila yung plants and seeing whether or not it grows. Tapos binabago nila yung composition ng water for the hydroponics, if I remember correctly. So to explain us more about CIDER, Sir Louis, would you be willing to enlighten us about what CIDER is about?
Thanks, Lawrence, sorry. Yeah, so one of the interesting things that's happening now is this whole CIDER program. And the takeaway from, I think, this slide is just we're looking at new ways to engage with both our other universities as well as industries, companies, and some of the government agencies like the Space Agency and ASTI. And one of the key things here really is, okay, can we build up a good enough ecosystem of IC designers locally such that we can have, a more competitive uh, industry, right? So basically, if you haven't or you're not aware, most of our exports, right, the Philippine exports are dominated by electronics. And out of that, around 70% is in semiconductors. And we have a bunch of companies doing a range of work from design to packaging to testing and so on. So there's a lot of potential, uh, and two, there's definitely a role for academe, not only the faculty, but definitely students and our graduates. And to do that, we sort of have two main thrusts here. One is the whole manpower development thing, and the other is on the research side. And the good news is that, okay, for Microlab students and faculty, we actually get to do both, right? Lawrence, can you go to the next slide? Okay, so we're talking about this whole researchy thing, and in the context of undergraduate students, you're trying to figure out what you want to do or which lab to join. And it's always interesting and obviously very fun to start building things, right? So when you start going to any lab in Triple E is exciting because you get to build different things. And most of these things, right, when you build them, you sort of pushing the envelope, trying to build something that has not been built before, or new takes on certain things. But sometimes we sort of lose track of what's really important, right? So, for example, when you start building stuff, like as you can see here, this nice little chip that we built, it has a bunch of things like energy harvesting, radio, communications, power line communications and radio communications. You have analog to digital converters, you have regulators, DC-DC converters, a processor, and so on and so forth. And that's a very, very fun thing and very satisfying thing to build. However, these are what we call artifacts, right? And it's very nice to be able to prove that you can actually build stuff and figure out how everything works and pave the way for future activities. But I think that really the more important uh, things when you do research is what you actually learn, right? And that's where the focus, at least for Microlab, and I think a lot of the labs, or all of the labs in Triple E, that's what we sort of want to make sure everyone understands, right? It's uh, the ideas and concepts that allow you to build these chips, not only now, but that allow you to build better things in the future, right? So one of the things that is usually what we tell our students is that you know your 198 or 199 or thesis or dissertation uh, is important because you learn stuff, but you think of it as your starting point, right? So the idea is we want to have fun, we want to enjoy doing this because we want to make sure that we can do this for the rest of your careers, right? So you do stuff now, but it's important. Okay, how can we learn stuff on our own so that we can continue doing cutting edge things? We can continue doing these exciting things after you graduate. If you go into grad studies or if you go into companies, you can still do all of these things, right? So uh, that's, I think, something that we sort of want uh, everyone to understand, and I think that that's pretty exciting as well. Right. Um, Lawrence, next slide, please. Right. So one of the things we probably will see is a lot of interaction with other universities. Uh, we do have a lot of interaction with Mindanao State, Batangas State, and even some of the uh, universities here, Ateneo, LaSalle, Mapua, and so on. Because the thing is, do want to build up this ecosystem, and for the industry to thrive, we need a lot more people. Right. So, for example, like Lauren said, we had some like 60 undergraduate students or more. Uh, and that's good. That's a lot. Right. But looking at it from the bigger picture, if you ask the companies how many engineers do we need in IC design, they're going to give you something in the order of thousands yesterday, right? So they needed thousands of these engineers yesterday. So even though we're producing a lot, it's not enough for the whole country. So that's why we actually are working with other people, and that's another thing, right? So when you start working at the lab, uh, there's probably you know a big chance that you'll probably be working side by side with some of the other students in other universities or other companies. So which is interesting, right? So we're starting to offer a lot of the joint classes. So last semester we offered an analog IC design class that's open to all our Cider partners. So we had something like 300 attendees or enrollees for that class. And we also want to continue that, right? So for that aspect, so it allows us to start thinking about things that we've never done before. So that's nice. And you'll probably see that when you enter the lab. But I guess for 199 or 196, you're more interested in what's the research thing? What's the projects that we can work on? Well, under Cider, we do have 4 different projects. And 3 of them are hosted here in Microlab, and the 4th is hosted in MSU, IIT Mindanao. And you'll see we have, you do have a range, like Lauren said earlier, there's a range of projects. The first project really is about very low energy communication. Right? So this is something I'm leading. And how can we sort of do a lot of these transmissions and so on with very low energy? Something in the order of picojoules per bit, right? Because you have sensor nodes, you're just looking at harvested energy. That means energy from the environment, right? Solar, vibration, thermal. Because you don't want to, replace batteries or even worry about maintenance. So you sort of want everything to be low energy and low power. So this is nice. So we're operating at an interesting range, 6.5 to 8 gigahertz. And there's a bunch of circuit problems that are very fun to tackle. Right? How do you deal with variations? How do you deal with varying supply voltages? How do you deal with all this wide temperature range and so on, but still get very reliable circuits, right? And that's, I think, one very cool focus of this. Again, yeah, it's nice to build a transmitter, but it's more important to understand, okay, how can we do this such that we meet certain requirements or optimize certain things? That's what we're focusing on. You do have the second project under Ma'am Tess. Lawrence is Tess gonna talk, so maybe Tess and Tata can talk or at least introduce some of their projects. But I'll just if for project 2, that's Ma'am Tess. They're working with the piezoelectric MEMS devices and interface to that, right? So that means on the circuit side, you have a bunch of data converters, you have a bunch of uh, you know uh, regulators and stuff like that. Uh, and again, it's really about trying to get information in and out of your MEMS system. And for project 3, which is under Mamtata, it's really about trying to figure out, architectures for machine learning, and how to overcome certain, let's say, mismatch, right? So currently, if you see, computation is a bit different when you look at very specialized type of operations. So again, this is sort of going to be a circuits heavy thing, but it's also going to be a computational theory heavy area, which is nice. Project 4, even though it's not directly under UP, we're still collaborating on that. It's under Jeff Hora, a faculty member of MSU IIT, and they're looking at energy harvesters for solar and I think vibration, but they're looking at multiple sources. So how to combine these sources of energy so that your chip can use that. Right? So again, these are sort of very broad topics, and even though again, there's going to be a few chips produced, like again, like I mentioned, these are artifacts, right? Within those chips, within those projects, are very interesting problems, right? How to build amplifiers that do this? How can you do computation more efficiently? How can you transfer energy from point A to point B? Or how can you, change or transform energy from one form to the other, and then store that or use that? So that's I think there's a lot of interesting sub problems that I think are very well suited as undergraduate projects. So, and again, these things are, like Lauren said, we sort of were using 65 nanometers before, but we are moving away from that. And since it sort of makes sense for us to do a more modern technology, and this is actually not updated, right? So this is 28, but we're actually going to tape out in 22 nanometers FDSOI CMOS. Right, so which is an even more advanced technology, which allows us to go faster and at the same time still reduce energy. Right, so this is something that you probably will see. All the circuits will probably be operating with power supplies of something like less than 1 volt, like 800 millivolts or so. And I think that that's another interesting area. There's a bunch of common things among the projects, right? So there's a lot of opportunities there. Okay, that's sort of, I think that's what I wanted to say about this. So again, we do have a lot of interaction, especially on the design of the chips. And we'll have companies and engineers from different schools and companies coming in for design reviews, for talks. So it's going to be, again, a more community-based, I think, experience joining the Microlab now. Okay, so that's it. Thanks, Lawrence.
Okay, thank you very much, Sir Louis. um, so yeah, that was Cider. As Sir Louis mentioned then, no, I will just emphasize this. Parang yung mga 196 and 198, no. We tend to try to try to suggest topics for for you all that are somewhat related to what Cider or what Care are working on. So parang specific project under Cider or specific project under Care, we try to suggest those types of topics. So you guys are hearing about it, and it's actually really relevant to what you will be doing likely. But of course, if you have your own idea, you can always just tell us, and we'll see what we can do about it. Kung ganun. So the other project is Care. Unfortunately, Sir Chard isn't here to talk about it, and we don't have the material to talk about it either. Kaso, Sir Chard did say that within the next few weeks they will announce some sort of activities under Care, where he likely will explain everything to uh, you all interested in in Care anyway. So look forward to that in the next few weeks. So moving on, so I will now be passing things to Sir Fred to give you all an overview of what the requirements are, what you will be doing in the lab, and what you can achieve in the lab and stuff like that. So hello, sir.
Hi, Sir Lawrence. Thank you. So now let's take a look at 196 or 199 at Microlab. So you may be wondering kung ano nga ba yung mga research topics na possible nating puntahan sa Microlab, no? So in general, we want to look at, of course, microelectronics. And ngayon, we want to explore technologies driving microelectronics, whether it be on sensors, computing, signal processing, energy harvesting, and so on. And generally, we want to look for technologies na recent, let's say from 2019 to 2030, 2023, and take advantage of the opportunities in this period. So essentially, gusto natin na yung capstone project na gagawin natin is relevant in this era so we can somehow contribute sa field na napili natin. However, although nabigyan na tayo ng overview ng mga topics na to sa mga past triple courses natin, kailangan pa rin natin, of course, magbasa ng mga books, conference papers, and journals para makita natin yung mga recent trends, para malaman natin kung ano yung mga current issues na currently sinosolve sa mga topics ito, and para malaman din natin kung ano yung mga currently ginagawa sa field na to. And since yung mga papers na to are technical in nature, we will have to apply what we have learned sa mga past triple courses natin, and kailangan natin silang basahin on our own. But of course, yung advisors naman natin will always be there to guide you in every step. Sige, next slide, sir. So here are some of the general topics natin for 199 sa Microlab. We have robust and resilient circuits. So that means na whatever yung variations natin sa device or circuit parameters, hindi yun dapat masyado maka-affect sa performance and reliability ng circuits natin. We also have non-CMOS devices. So sa non-CMOS devices, we have spintronics, memory stores, saka yung MEMS. So yung MEMS, mamaya i-discuss naman to in more detail ni Ma'am Jean. Sa spintronics naman, isang name dito is magnetoelectronics. So dito sa spintronics, aside sa parang electronic charge na meron ng isang electron, we also use yung parang intrinsic spin niya and yung magnetic moment. Kaya din siya tinatawag na magnetoelectronics. So dito meron pa rin tayong concept of ones and zeros, logic high and logic low. So this is commonly used, for example, sa mga memories natin. So aside from the non-CMOS devices, we can also explore yung mga low voltage, low power, and energy efficient circuits. Of course, there are some devices na energy constrained or very limited yung amount of energy na meron sila. And so sa mga applications or devices ito, very essential na lahat ng modules na ilalagay natin ay energy efficient or counting memory or counting amount of energy lang yung kailangan nilang i-consume. So clock generators, for example, kapag kailangan natin silang ilagay sa digital circuits or for synchronization, we can design them na very energy efficient sila. We can also implement low voltage memories. Also, kaya rin natin mag-implement ng, next sir, kaya rin natin mag-implement ng mga energy efficient na ADCs or DACs. So ADCs are analog to digital converters, in DACs naman yung kabaliktaran. So sa ADCs, nakita na natin to sa 188. However, doon sa 158, nalaman natin how we can configure yung registers ng microcontroller para magamit natin yung ADCs for a certain application. For Microlab naman, we will design ADCs mismo. So do we have to implement it na energy efficient? Or kailangan bang mataas yung resolution niya? Or kailangan bang mabilis siya mag-convert? So lahat ng yun, nakaka-affect sa pagpili natin ng topology, for example, dito sa ADCs. And ganun yung mga usually pag-aaralan natin dito sa Microlab. Aside from that, we also have energy harvesters. So dito naman sa energy harvesters, yung idea is we want to exploit yung energy na available sa environment para yung mga devices natin na energy limited ay mas maging self-maintaining and para mas mapahaba natin yung lifetime nila. So maliban doon, we can also design adaptive circuits, so more on closed loop systems naman yung titingnan natin dito. And lastly, we have yung digitally assisted analog circuits. So dito sa mga digitally assisted analog circuits, meron tayong mga dinedesign na analog circuits, and if we want to improve yung performance nila, we can use yung properties na meron ng digital circuits, for example, robustness, hence yung term na digital assisted analog circuit. Sa analog assisted digital circuits naman, kabaliktaran naman, we have digital circuits and we assist them with analog circuits. Next slide, sir. Okay. Yep. So by researching and studying mga topics na nabanggit natin kanina, we were actually able to publish numerous papers on different conferences and journals. And dahil din dito, we were able, or some of the students were able to travel around the world. So we have Japan, Korea, Jordan, Malaysia, France, and Canada. And actually, ilan lang to sa mga countries na napuntahan ng mga Microlab affiliates natin over the last few years. So we have, for example, here, TenCon. So that is IEEE Region 10 Conference or IEEE Asia Pacific Region 10 Conference. So itong TenCon, inattendan siya ng mga undergrad and graduate students natin. We also have, for example, here, ISOC saka TenSIP, which were held naman sa Korea. So yung sa ISOC and TenSIP, nakapag-publish tayo ng around 9 papers. And dito, sina Sir Steven, sina Sir Z, ayan, nakapag-publish sila sa ISOC, sina Sir Lawrence din. And then we have ICM naman, International Conference on Microelectronics, si Sir Jairus, I think. Nanalo siya ng Best Paper Award dito. And si Kuya Ian. Meron din tayo sa Malaysia, sina Sir MD Alea. Tapos meron din tayo sa France, yung IEEE Wireless Power Week or WPW na inattenda naman ni Sir Herlan. We also have yung EHST saka yung parang Journal of Fluid Flow, Heat and Mass Transfer, FFHMT, na si Ma'am Jean naman yung nakapag-publish doon. Okay, so lahat ng papers na to, available naman siya doon sa link na ito. Sa Sir Lawrence, yung link. Nasaan? Ayan, sa up-microlab.org/publications. And next slide, sir. And to give you an idea lang, here are some pictures taken during the conference period. So these are images from 2019. Nandito sina Sir Chito. Ayan. Sina Sir Herlan. Tapos dun sa may upper right, nandiyan si Sir Chard, Sir Mark, saka si Ma'am Kata. So these are images from the ISOC and ISMAC na conferences. We also have yung images from 2018. 2018, next sir. So ito, 2018. So dito kami na Sir Z naman yung nag-present bilang pinesent namin dito yung mga undergraduate projects namin doon sa COE 198 or EEE 198. However, dahil nga sa pandemic, lahat ng recent publications natin ay halos presented virtually. Pero ngayon, TenCon, for example, is scheduled to be held around October to November, and yung location niya is Thailand. Sa TenSIMP naman, mangyayari siya around September sa Australia. So in short, maraming opportunities para makapag-travel tayo or maraming opportunities para makapag-publish tayo ng papers sa iba't ibang conferences. And of course, initially, we may think na baka mahirap makapag-publish sa mga conferences na to. Well, that is true. Yung advisors naman, of course, lagi kayong gag-guide and isa-support sa inyong undergrad na capstone project mula sa pagpili ng research topic hanggang sa part na i-defend na mismo yung project nila. So, yun yung sa travel opportunities. And then next, sir. So in terms of yung application, ano nga ba yung mga kailangan natin para maging affiliate tayo ng Microlab? So these are the required coursework. So yung mga elective na kailangan nating i-enlist or kailangan nating i-enroll ay yung COE 197U, saka yung ECE 197U. Take note or, so sa COE 197U, this is the Introduction to Analog and Digital IC Design. So this is a required elective, and this is usually given every second semester. So this coming semester. And ngayon, para makapag-enlist tayo sa COE 197U, waitlisting yung ating magiging process. So after this application, i-allow na namin yung mga waitlist na yan. And another one is, if you want naman na MEMS topic, yung puntahan yung research topic, we also have yung ECE197U. So this is the introduction to MEMS. And mamaya bibigyan tayo ni Ma'am Gino more details on what ECE197U is. Okay, next. Aside from that, these are the required trainings natin for Microlab. Yung una is yung paper reading sessions. So this is to be decided either kung kailan siya gagawin, either during the SEM or during mid year. So sa paper reading sessions, from the name itself, magbabasa tayo ng papers. So dito sa part na to, ipe-present natin yung mga nabasa nating papers sa either graduate students or sa faculty members. And ang goal lang dito is, parang pinaka-objective dito is more on, gusto namin matuto tayong lahat kung paano efficiently magbasa ng paper. Of course, masyado tayong maraming papers na kailangan basahin. Pero we want you guys to learn paano nga ba magbasa efficiently. That means ano nga ba yung mga kailangan nating tingnan when we want to search for a certain research topic and so on. And dito rin, tutulungan din tayo how to present, right? Tutulungan tayo paano nga ba i-present, for example, yung mga results ng isang paper in a proper way, ano nga ba yung laman ng presentation natin dapat, and so on and so forth. Aside from that, meron din tayong mga tool training. Sa tool training naman, usually, kasi hindi lahat ng mga tools ay tinuturo sa atin during the undergrad. And minsan yung mga research topics na pupuntahan natin during our 196 or 199 requires tool na, ayun nga, hindi pa naturo sa atin. So, during the first SEM or second SEM na tinitake natin yung 196 or 199, magkakaroon tayo ng mga tool trainings for that. For example, pwede nating pag-aralan yung Verilog. I think nabanggit naman ito sa mga past Tripoli courses ninyo. So ayan, pag-aaralan natin how we can use Verilog or ano nga ba yung mga tools na pwede natin gamitin in order to implement yung mga Verilog ng mga codes. Okay. Next slide, sir. So COI 197U, again, is yung introduction natin to analog and digital IC design. And yung mga prereq na subjects niya are EEE 41 or EEE 131, so semiconductor devices. And yung mga topics natin or concepts from EEE 51 or EEE 141, wherein ginamit natin yung transistors in order to implement electronic devices, ay magiging useful din naman. So dito pumapasok yung parang mga amplifiers and so on. So yung coverage natin for this elective, again, is yung introduction nga to integrated circuits. We want to discuss what integrated circuits are. And i-discuss din natin kung ano nga ba yung difference between analog and digital circuits. So sa digital circuits, konting overview lang. We will discuss yung mga logic gates, so yung mga NAND or inverter. Tapos mag-discuss din tayo ng mga sequential circuits such as mga latches, flip-flops. And siguro magkakaroon din tayo ng overview on memories. Ano nga ba yung mga memories, what are SRAMs and DRAMs. Sa analog circuits naman, again, yung mga amplifiers natin. And to implement amplifiers, of course, i-discuss din natin yung mga current sources, yung mga single-stage amplifiers. And lahat ng to, although hindi naman natin kailangan alam agad, matututunan din naman natin or malalaman din naman natin sa COI 197U. And aside from that, para makapag-implement tayo ng mga integrated circuits or mga circuits, we will use industry standard na software tool. So this tool will allow us to, for example, make our schematic, to simulate our circuits. And although hindi siya i-discuss specifically for COI 197U, yung tool na gagamitin natin is also or can also be used sa layout purposes naman. Okay. Ayan. So yan yung MOS device natin. And MOS or pins. Sige, next slide, sir. So with that, ito yung mga recent undergraduate projects natin. So ito yung mga undergrad projects this year or this academic year. So we have yung sa digital na part, more on computing yung tina-target nating tingnan dito. So una siguro we have here, medyo mahaba, no? Medyo mahaba yung parang mga names sila. Pero pa-highlight, sir, hyperdimensional computing. Ayan. So sa hyperdimensional computing, it's a computing na energy efficient. So it is an alternative to machine learning algorithms na medyo familiar na tayo. And dito, kaya natin tina-target gumawa ng HTC is gusto natin na i-apply siya for classification tasks. And yung classification task na ang target for this project is yung speech recognition. So we want to implement an energy efficient speech recognition using hyperdimensional computing instead of machine learning na mga algorithms. Next naman, we have here a RISC-V vector coprocessor. So sa parang mga artificial neural networks natin, marami tayong massively parallel workloads, marami tayong multiply, accumulate, and multiply accumulate na operations. And gusto na sana natin doon na wag natin siya ilagay sa processor or instead gumawa tayo ng co-processor that will handle all those workloads. Kaya dito sa second bullet, ang target is to make a RISC-V vector co-processor that is intended for ANN applications. And lastly, we have here in-memory computing. So sa in-memory computing naman, I guess very familiar kayo sa von Neumann architecture. So hiwalay parang, or at least, ayan, sa von Neumann architecture. Hiwalay kasi yung parang sa data sa yung sa processor natin. And usually, to transfer or to implement or to compute something sa processor, we have to fetch data muna from the memory. And yung latency na yun ay usually mataas. And dahil doon, dahil mataas yung latency, for example, nung pag-transfer ng data from the memory to the processor and back from the processor to the memory, nagkakaroon tayo ngayon ng bottleneck. So dito sa in-memory computing, we want na ilagay yung computing sa memory mismo. Kaya siya tinatawag na in-memory computing. And yung parang focus natin dito sa third bullet is more on toggle spin torque, magnetic random access memories naman. Right? Okay, and then next naman, so we also have projects na ang applications ay biomedicals and wearables. So for example, dun sa una, sa first bullet, we want to implement, for example, receiver designs for portable muscle oxygenation monitoring systems. Sa third bullet naman, for example, ang target application natin ay mga EEG systems. And then, sa second and fourth bullet, ganun din, biomedical pa rin yung parang applications natin or wearable applications. Pero dito parang may tina-target tayong designs. So dito sa second, we target na mga amplifiers. So we want to exploit yung parang properties ng ating technology in order to investigate the effectiveness niya for the voltage scaled and PVP invariant ng mga amplifiers in these applications. And lastly naman, this sa fourth bullet, discuss ay yung mga target natin is thermoelectric energy harvesting system naman for wearable device applications. Pero dito, ang dinedesign natin mismo is in charge pump circuit lang. So specific circuit under this energy harvesting system. Okay? And then next, ito medyo mahaba. Pero I guess sa care, ang mostly target natin is for air quality monitoring ng mga systems. So yun, ina-highlight ni Sir. And dito, siguro mas mabibigyan tayo ng more detail ni Sir Chard kapag diniscuss niya ng care in more detail. So,
Ako, dagdag ako konti.
sige Sir Mark, go ahead po.
Sige. So currently, yung mga version ng project na to is puro lahat embedded systems using microcontrollers. But what we're looking at is after siguro implementing these systems in embedded systems, microcontroller-based designs na activities, somehow some of these activities could be transitioned or implemented in FPGA-based systems, o kaya may mga analog circuits that could be useful sa environmental monitoring. So just a brief background, ang daming projects ito, but these are mainly embedded systems types na project. And ang ginagawa nila is nagmo-monitor ng environment, air quality, noise, marami pang iba in relation din to dun sa mga naging activity on monitoring sa sensor networks for hydroponics. Now, so you see, from here, what we want is to have some projects na merong IC flavor. So alin dito sa mga project ito or sa mga nasimulan natin dito, yung pwedeng magkaroon ng could be implemented, or some minor circuits or some major parts ay kayang gawin using integrated circuits. So it's either through the MEMS type, o kaya it's either yung kumbaga yung mga MEMS systems, or kaya sa circuits, or sa mga digital systems probably using FPGAs. So yun yung next na parang development after implementing these systems in microcontroller-based implementations. So yun lang.
Sure.
Thank
Question
you.
ko lang po dito, no?
Yes.
Etong, di ba, ang dami na itong care na project natin nakalista dito. Ito yung related lang sa EEE, no? So marami pa tayong like projects na hindi EEE yung gumagawa, or ito na lahat?
Yung care, parang triple related lang to, kasi yung care collaboration siya with College of Science, yung environmental group, saka yung mga triple ME saka ChemEng. So merong mga ibang activities doon. So baka may mahanap tayo na somewhere pwede mailagay on may IC design na flavor yung mga activities. So but for now, ito yung nasa isang project. May 3 pang project na hindi naka-mention dito.
Thank you, sir.
Okay.
Salamat po. Okay, so yun nga yung mga projects natin under computing, saka yung mga applications natin for biomedical and wearable devices. So now, aside from COE 197U, isa sa mga elective na pwede nating i-take ay yung ECE 197U. So, Ma'am Jean, are you here?
Hello, thank you, Sir Fred. Hello, everyone. Good morning. So, yung ECE 197U or the Introduction to Microfabrication and MEMS. Yung MEMS is Microelectromechanical System. So, basically, magkuha nyo dito yung learnings on the different microfabrication technology. Ano-ano yung mga different processes that you can use in order to fabricate a device using MEMS technology. And of course, yung mismong MEMS, how to model MEMS devices. Ano ba yung MEMS? So for some of you na hindi pa, or first time pa lang na-encounter, what is MEMS? So basically MEMS, they're composed of parts in micro range, such as yung mga microsensors, microactuators, and etc. And yung mga parts na yon, they can interact with each other, or if not with each other, maybe to an external part. So in a nutshell, we combine the mechanical and electrical components and fabricate them using some semiconductor fabrication techniques. So more specifically, MEMS process, not CMOS process, because usually yung CMOS, yun yung ginagamit to fabricate the transistors. And in the current laboratory that we have in UP, we are doing MEMS process in a micro range. So ECE 197 actually has been taught for about 5 times already, if I'm not mistaken, since its first offering by DocTest. So the first one, I think there is no laboratory component yet. But is face-to-face. And then the 3 offerings, which are consecutive with lab component siya, but because it's pandemic, so walang face-to-face laboratory. And then currently, so it will be offered this semester. So first time namin yung offer yung laboratory component in F2F mode. So you will be learning and experiencing different MEMS processes that, for example, device process engineers do to fabricate a device. And of course, when we fabricate a device, one major requirement is the provision of a clean room facility. So ano ba yung clean room facility? It is basically a laboratory that controls the pollutants and particles that may contaminate your device. So it is a controlled environment. And ito lagi namin sinasabi sa project, this is actually first in the country na laboratory. So it is really a great opportunity for everyone to gain the skills on how to work in a clean room. And if you are interested to know more about UPDMF, so ito yung pangalan ng ating clean room na nakahouse sa Department of M. Katabi lang siya ng EngLive, which is yung EngLive katabi ng EEE, so magkalapit lang sila ng building. You can scan the QR code here to know more about UP Diliman Microfabrication Facility. So in ECE 1, furthermore, in ECE 197, you will be learning the different, of course, device microfabrication technology, laboratory safety, and the different chemicals to use. Kung paano natin ginagamit ng mga chemical na to, because some of them are hazardous and dangerous. So aside from that, you will be taught on different fabrication equipment. So gagamit kayo ng mga fabrication equipment in the laboratory, and you will be taught on the different processes kung paano gamitin yung equipment. Plus, the new addition in this laboratory component is the device modeling. That you will be, so similar to COE 197U, yung mga offering ng COE 197, you are taught on how to characterize a device and model them. So most likely yung mga transistor natin on specific flavors. But in ECE 197U, yung mga device na imo-model nyo as for this semester is the sensor itself. So, paano ba natin malalaman kung paano gumagana yung chosen sensor natin or yung chosen device? How can we extract parameters to analyze them? So, doon natin yung matututunan sa part ng modeling ng ECE197U. And next slide, please. Thank you. So, current undergraduate projects naman ng ECE, not ECE1, related to ECE197U, but is closely tied up to CIDR Project 2. So, na-mention kanina ni Sir Law or ni Sir Fred yung about sa CIDR program. So, basically, yung CIDR Project 2 is entitled yung Model-Driven Co-Design of MEMS-Based Sensors and Interface Circuits. So, basically, ito yung pinakabagong project na ginagawa in the clean room facility. So, yung goal ng project na to is to explore yung interaction ng sensors, MEMS-based sensors, and yung corresponding interface circuits nila. So, with that being said, from the goal of the project to co-design nga yung sensors and yung corresponding interface circuits, yung mga undergraduate projects natin includes modeling of the two types of sensors, which is yung for the semester, pressure and temperature sensors. And of course, the common circuits na gagamitin natin so that we can interface the sensors and convert and process the sense signal. So this includes OTA, SAR-ADC, LNIA. And yung mga OTA, SAR-ADC, LNIA, some undergrad are exploring the effect of body biasing in those circuits. They designed the SAR-ADC for sensor readout and the LNIA for signal conditioning. And not only that, the research study even extend to how machine learning can be applied to MEMS. So for example, we have one group that explores machine learning for human activity recognition, or yung human activity recognition or yung HAR can be used to detect maybe for fall detection, disease prevention, navigation, etc. So if you're interested in fabricating the device and excited to learn how you can interface a device to a circuit, you take ECE197U or join Microlab. So I think yun lang from my end, unless Doctor wants to add something. Otherwise, I'll turn the floor back to Law and Fred. Thank you.
Okay, thanks, Ma'am Jean. Ma'am Tess, would you like to add something po?
Hindi na. Mukhang na-cover naman na ni Jean lahat. Thank you.
Salamat po, ma'am. Okay, thank you, Ma'am Jean and Ma'am Tess. So next naman nung part nung orientation. So dito, nanghingi lang kami nung parang feedback from some of our 196 and 199 students this semester or this academic year. And tinanong namin sila, why did you join Microlab? So sige, try lang nating basahin from yung doon sa una. So I took COI 197U dahil naging interested ako sa topic sa 131 and 141. And dahil na rin siguro sa pag-handle ng course, especially kay Sir Z. Sir Z. And hindi naman ako nabigo kasi sobrang organized ang pag-handle ng Microlab sa COI 197U. So if you're looking for responsive professors na i-guide kayo throughout the modules, hindi kayo magsisisi raw sa pagpili ng Microlab. Magiging madali lang yung transition from 197U to 196 dahil sisiguraduhin ng Microlab na may background ng students sa mga possible topics, pati na rin kung paano ang proper paper reading and presentation. So dito yung parang paper reading sessions that we have discussed or mentioned earlier. Plus, may pa-price lagi si Sir Rai sa Discord dati. However, wala na si Sir Rai, nasa Belgium na siya dahil sa kanyang PhD studies. Okay, so mostly ng mga parang naging feedback dito is dahil yun, na-enjoy nila yung mga topics nila sa 131 and 141. So naging interested sila how they can use yung mga transistors in order to make electronic devices. So dito naman sa pangalawa, sige, last na. So si Angela, nag-join daw siya ng Microlab dahil yun lang yung attended na orientation. Kidding aside, she was motivated to join this lab mainly because of the very kind and understanding mga faculty members who made the topics interesting and fun and made sure that we learn each lesson by heart. So while the research topic sounded intimidating to me at first, she still pushed through in taking COI 197U and eventually pursued 196. because I learned a lot from the elective, starting with reviewing the basics up to making their own designs. We were also taught topics in digital and analog design that would be very much helpful in the long run, especially in our future careers. Finally, the advisors made sure that we get the support and guidance that we need in formulating our research problems, which is one of the things that I really like best in Microlab. So there. So siguro since nandito rin naman yung ibang mga Microlab affiliates natin, gusto sana nating tanungin, no? Bakit nga ba sila nag-join ng Microlab in the first place? Sir Z? On the spot tayo rito.
Wala akong kawala sa iyo eh. Hello, good morning. Yeah, so ba't ba ako nag-join sa Microlab? Actually, nung una, peer pressure. Inaya lang ako ng friend ko. So may options ko yung ibang lab. Although yung Microlab yung una kong natendan. And then, exciting din kasi so microelectronics, hindi siya, pag nagtanong kayo sa ibang students sa ibang universities, hindi nila alam or hindi sila familiar doon. So parang, ano yun? Ganyan. So yung alam lang nila yung diode na may 0.7 na drop. Samantalang tayo, alam natin yung mga PN junction, yung mga VBI, ganyan-ganyan. Tapos hindi nila alam na nare-resize yung transistor, yung mga MOSFETs, ganyan. So iba yung turo sa Microlab, or at least in UP in general pagdating sa microelectronics. So interesting siya, and nung time na yun, syempre gamer, ganyan, medyo interested sa processors, sa mga video cards kasi diba, pag gamers usually yung specs, yung mga rig nila gusto nila matataas. Tapos maririnig mo Microlab, uy, may direct influence ako sa industry na yun. So yun, kaya academically speaking, naging attune ako dun sa pag-join sa Microlab. Moreover, yung mga advisors, sobrang caring nila. So, ang bilis nila mag-reply sa email pag may problems ka or may feedback. So, hindi tulad ng iba na hindi nagre-reply agad. Yung mga Microlab advisors, minsan isipin mo kung natutulog pa ba sila or hindi kasi ang bilis silang mag-reply. Tapos, hindi sila yung reply na mema lang. Sila yung reply na thorough yung feedback, positive or negative. And hindi ka you will not feel you will not feel down kung sakaling negative yung feedback nila kasi alam mo na pinapoint out lang din nila yung point for improvement mo. Yan. Moreover, may maingay sa gilid. Yan, so moreover, nung time ko rin pala, nung application namin, may interview. Yan, so yan, ulitin ko yung sagot ko last time. So may interview nun. Tapos isa sa mga nag-interview sa akin, natuwa siya. Sabi, uy, I like you, ganyan. Para ka inosente, yan. So, syempre ako pinilig, Hi, I like you to ate, ganyan. So, kaya, yan. So, nag-join ako sa Microlab, yan. Yun lang.
Salamat, Sir Z.
Ngayon ko lang narinig yun,
Grabe naman yung ating
Sino kaya si ate?
name drop daw, sabi ng advisors.
Oh. Ikat na lang.
Okay, sige. Maliban doon, meron pa ba tayong ibang mga Microlab affiliates na gustong i-share yung mga
Sir Steven.
gusto mag-share?
Diyan si Sir Steven, Sir Herlan.
Nandito ba si Sir Herlan?
Hello.
Ayan, Sir Herlan. Hi.
Ayan, katabi ko lang si Sir Z. Pinaka gusto ko sa Microlab is yung malaki yung range kasi technically lahat ng ibang lab sa Tripoli kaya mong gawin yung ginagawa nila. So pwede tayong magkaroon ng power electronics pero maliit. Pwede tayong magkaroon ng signal processors pero maliit. Pwede tayong gumawa ng communication circuits pero maliit. So everything but smaller. So parang kung ayaw mong malimit yung range mo, and ayun, parang may experience mo rin lahat sa Microlab. Kaya ayun, yun yung pinaka nakakuha ng interest sa akin. And then ayun, i-echo ko lang yung sinabi ni Sir Z about dun sa experience as an affiliate. ayun, yun nga, mahirap makapasok sa mga conferences pero with the help of your co-affiliates and the advisors, dumadali siya. And ayun, kung gusto mo din mag-publish, makapunta sa France. Ayun, masaya sa Microlab. Ayun lang, thank you.
Alright, thank you Sir Herlan. Sige, maliban doon, meron pa ba?
Sir
Gusto
Fred,
pa
ikaw
bang
po ba?
mag-share?
Ikaw, Fred.
Ako, sige. Ako, nag-join ako nung Microlab kasi nagustuhan ko yung topics dati sa 41. So yung 41 semiconductor devices and theory. Tapos siguro yung 41 meron siyang parang may notion yung mga students na mahirap yung 41. Pero siguro nung time na diniscuss siya or time na nag-aral ako ng 41, medyo na-enjoy ko siya kahit na medyo mahirap may topics, kahit na medyo mahirap minsan yung mga exams. And yun, siguro tinuloy-tuloy ko na lang yun, yung parang nag-join ako ng parang, or kumuha ko ng mga electives, specifically yung digital and analog IC design. So yung mga naging professors ko dun sa digital design na IC is si Sir Snap, while doon naman sa analog IC design si Ma'am Tess. And doon sa mga electives na yun, marami ako natutunan essentially. And siguro dahil mas na-enjoy ko pa in more detail yung parang analog and digital IC design, tinuloy-tuloy ko na siya hanggang doon sa part na undergrad capstone project. So yeah. Ayun. Tapos dahil nag-enjoy din ako sa undergrad capstone project, tinuloy-tuloy ko rin siya hanggang MS. Hanggang MS studies. Yep. Yun. Sir Lawrence, ikaw gusto mong mag-share?
Nuami answer ko, sir eh. So ako din actually. So I really, really loved 41 kaya ako pumasok ng Microlab. To be honest, I really had no other no second choice, no, Microlab lang sa akin. Saka I also really loved the profs. So, Sir Adel only had one lecture, but I was like, Sir Adel, so good. Tapos si Sir Rico din. So, Sir Maestro, he was really so good as well. And, I never had Sir Rai as my, as a teacher back in undergrad. So, I saw how Sir Rai teaches and like, so good. Sir Fred din ang 197 ko. So, yeah, it's I mean, we also saw din naman sa mga testimony ng ating mga current 196 at saka mga 199, parang most of the like a big part of the reason why they end up choosing Microlab is because parang caring yung mga prof natin dito, tapos masaya sila magturo. So it's really essentially the same reason for me.
All right. With that, we would like to open the floor sana kung meron kayong mga questions or clarifications or any concerns from anyone. Sige, pwede kayong mag-leave dun sa chat window natin ng mga questions niyo, or you can unmute and say them directly na lang. Okay, so may nagtanong dito. So will the course be conducted in a fully face-to-face setting? So for COE 197U, magiging hybrid yung setup natin. Yung mga lecture components natin will mostly be online, and yung mga laboratory experiments naman natin will be in the lab. So face-to-face yung ating sessions doon. Now for ECE 197U, Ma'am Jean, meron po ba tayong insights dito?
Okay. Yung sa ECE 197, yun naman, yung lecture niya, face-to-face, pero yung laboratory, yung parang magiging hybrid because we are limiting the capacity of the laboratory, maximum of 5 students per class. So, since merong dalawang section and 10 students per section, say for example, the first week, yung first 5, sila yung papasok ng lab, and then the other 5 students, sila naman yung gagawa ng remote laboratory, which is yung modeling na part. So, and then in the next week, mag-exchange naman sila ng work. So, parang ganun yung magiging setup, mag-alternate. Kaya may hybrid yung lab.
Okay, thanks Ma'am Jean. So yun, for COE 197U and ET 197U, yung magiging setup natin, hybrid. And when will the CRS waitlist for COE 197U be processed po? So after this orientation, yung mga faculty members, Microlab faculty members, ano na siya. Pero pa-process na yung waitlist natin. Okay? And then, okay. May nagtanong dito, are there already lecture videos online sa COE 197U from previous semesters? I think meron mga available na lecture videos online from the previous semesters. So, nandun naman siya sa Microlab website natin. So, yung Microlab website natin is up-microlab.org. Pasulat na lang Sir Lawrence. Ito, si Ma'am Tess yung nagbigay. Thanks, Ma'am Tess. So yan, lahat ng mga resources natin for 197, pwede nyo siyang i-run through dito. Pwede nyo tingnan. Okay, next question is, due to the subjects I got in my schedule this sem, mukhang hindi po ako makaka-enlist for 197 without conflict with my other enlisted subjects. Is there no way around this po? Nag-open po ba Microlab or PREC elective during mid-year or next sem na lang po, next opportunity? Thanks po in advance. Actually, ino-offer lang natin yung 197U sa 197U every second semester. And kung meron tayong conflicts, Ma'am Tata, Ma'am Tess, meron po ba tayong pwedeng masuggest sa kanila dito?
Hindi ko na-catch. Ano yung conflict ulit? Major.
Hindi po specifically sinabi, pero may mga ibang courses daw po siya na.
Oo, yun. So, if you're really keen on getting yung elective ng Microlab, then you would have to move yung conflict na yun. Kasi, mas mahirap i-move itong schedule nung COE 197U sa ngayon dahil may mga naka-reserve na yung rooms, 'di ba, sa ibang classes din. And yung faculty rin may iba pang tuturo.
Okay, salamat po Ma'am Tess. So yun nga, kailangan natin i-re-enlist siguro yung mga conflict subjects natin. Okay, tapos next ay ayun, yung isang question is more on the conflict din. Kung meron po bang available schedules na hindi second sem. Okay, so fortunately, second sem lang usually ino-offer yung 197 tulad na sinabi or na-discuss din kanina. So, if meron kayong conflicts, then tulad na sinabi ni Ma'am Tess, kailangan natin i-re-enlist yung mga other subjects natin. The next question, open po ba for EE students yung Microlab? Yes, actually open siya sa lahat ng EE students natin kahit na COE yung course mo, ECE or EE. Again, tulad ng sinabi ni Sir Herlan, marami tayong parang pwedeng fields sa pwedeng puntahan dito sa Microlab. So kahit na EE yung course mo, then definitely pwede pa rin tayo mag-apply dito sa Microlab. So open siya sa lahat ng students. Ayun, so if power mostly yung gusto mong tingnan, then definitely pwede rin natin siyang tingnan dito sa Microlab. Okay, next, will the schedule in CRS be followed or is it just a placeholder? So yung, for example, yung sa 197U na lab, is COE 197U na lab, ipa-follow natin yung nakalagay sa CRS. And since yung mga lectures naman natin ay hybrid, well, then pwede natin siyang gawin either during sa CRS na schedule or sa free time natin. Pero yung lab natin ay mostly gagawin natin during the schedule sa CRS. Okay. The next question ay, how many students will be accepted in the waitlist? I think, sige, let me check. Siguro less than or approximately 30 students yung i-accommodate natin for 197U. Kasi merong dalawang sections dito, right? Tapos siguro around 15 students, 15 to 18 students per section yung kaya natin i-accommodate. Okay. And the next question ay, sure naman pong mag-grant yung waitlist po kung wala naman pong conflict? Yes, If wala namang conflict and if okay naman yung mga prereq subjects natin, then dapat mag-grant na sa atin or mapoprocess na yung basis natin. Okay, do we have to be affiliates of Microlab after completing OE or ECE197 or can we still change our mind? Okay, so if you have completed na yung COI 1 or after nyo ma-complete yung 197, hindi naman necessarily kailangan ninyong parang gumawa ng capstone project ninyo under Microlab. Of course, pwede nyo pa rin siyang gawin, pero since nakapag-take na kayo ng COI 197, we encourage you na parang gawin na yung capstone project niyo under Microlab, right? Okay. Okay, isa pang question. Hanggang 20 students lang po ba yung ECE 197? Ma'am Jean, Ma'am Tess?
Oo, kasi yun nga, no, as Jean mentioned, medyo limited pa kasi tayo ngayon dun sa capacity ng lab. So pag in-expand namin siya ng more than 10 per lab section, mahihirapan kang gawin yung plan namin na alternate na hybrid ng lab. So ano naman, no, yung ECE 197U naman, hopefully ma-offer pa rin namin ulit ng first sem. So, kasi ito yung first offering ng lab, kaya ayaw din namin na face-to-face na lab. So kaya ayaw din namin na masyadong mag-overbook. Ayun. So hopefully maintindihan ng mga hindi nakakuha.
Okay po, salamat Ma'am Tess. Okay, other questions or concerns? Okay, sa mid-year po ba mag-offer yung 197U? ECE 197U? Ma'am Tess, sorry po ulit.
Mid-year?
Opo.
No, medyo mahirap yun kasi lalo na 5 weeks lang yung mid-year.
Okay po, thank you ma'am. Is it possible or recommended to take both COI 197U and ECE 197U? Well, if you want to have an overview of both analog and digital IC design sa kayong MEMS, then possible naman siya na i-take parehas. Would I recommend it? Well, siguro baka kasi maging heavy lang sa lab yung kung iti-take natin both subjects or both courses. Pero definitely, you can enlist both courses naman.
Follow-up kung question doon, no, Sir Fred. Anong plans natin, right? Kung parang 'di ba nag-take ng ECE 197U and then all of a sudden nung topics na they want to be under say computing or stuff like that. We allow that, right?
Wait, sorry na. Paulit ng question. Sige po.
I mean, pwede naman, although that's going to be a disadvantage for the student kasi kailangan niya mag-catch up. Although, I guess, no, kung yun yung interest niya, kung mas nasa computing, tapos unfortunately, hindi siya nakakuha ng COE 197. As long as nandun naman yung interest and yung motivation to learn things as you go along, kaya naman dapat. No? Ang ginagawa lang naman talaga natin, kaya tayo nagre-require ng COE 197U is to help them prepare. Pero may mga students naman tayo na let's say nag-COE 197U before, pero ngayon ang topic nila sa 196 ay mas nasa device. Okay lang din yun. Kasi during the paper reading sessions, during the discussions, before ng 196, mas lumabas na yun yung interest nila. Tapos yun nga, kagandahan is yung mga materials naman readily available na so they can actually study them on their own.
Thanks, ma'am. Oh, you all heard, ha?
Alright, meron pa bang ibang questions or clarifications? Going once. Ayan, meron pa. Pwede po ba maging affiliate ng Microlab kahit hindi mag 197? Okay, so tulad ng naging discussion natin kanina, required na mag-take tayo ng either COI 197 or ECE 197 bago tayo maging affiliate ng Microlab. Kasi kailangan nga natin yung parang mga, or parang it would help us to know kung ano yung mga topics under Microlab by taking these electives. Okay. Okay, may isa pa palang question dito. Sir Mark, baka pwede niyo pong sagutin ito. So CARE is a different lab po from Microlab, right? Or is it a subgroup po?
CARE is a research group na marami sa EEE yung kasama. So galing from different labs. So ano siya, parang open lab thing. So it's a research group, yung iba galing DSP, merong nasa CNL, CNL sa yung SS nga ibang grupo yon yung yun. So it's from different, yung mga advisors doon from different labs. So yun. So normally ang nangyayari doon is some would be affiliated directly doon sa main lab nila, and then yung topic would be coming from the CARE group. Parang ganun. So some students will be coming from ibang research lab, tapos kung may requirement sila doon to join there, and then yung topic nila eventually related doon sa air quality monitoring na activities. So parang ganun siya. Hindi siya separate lab, it's a research group. People from different labs na may halos same interest na application. Yeah. I hope that answers your question.
Salamat, sir. Okay. Mga pahabol na questions? Okay, sige. If wala na, we would like to thank you mga advisors or mga faculty members natin for attending this applicants orientation. And also kayo, we would also like to thank each and every one of you sa pag-attend dito sa Microlab applicants orientation. So I guess yung pinaka-objective lang natin dito is to introduce Microlab sa inyo and para malaman ninyo kung ano nga ba yung mga required coursework para maging affiliate tayo sa lab na to. Okay, I hope marami kayong napulot na mga insights. I hope marami kayong napulot na parang ano nga ba ginagawa sa Microlab. And hopefully, ang pinakagusto natin ay mag-join tayo ng Microlab. Yeah, join Microlab. Yep. So again, thank you everyone. Sir Lawrence, meron ka bang mga pahabol?
Wala na. So, thank you everyone for your time. Thank you students for showing your interest. Thank you faculty for saying hi to the students. Yun lang.
Okay. Okay, again, thank you everyone and hope we can see you all sa room 403. Okay, thanks everyone. Siguro ano na lang, picture na lang tayo. Yep. I-invite na namin lahat na mag-on cam. Tapos take lang siguro kami ng picture. Okay lang ba yan? Hi. Yeah. On muna tayo ng
Stop
camera.
share na kayo para mas
Sige.
kita.
Sir Lawrence. Sir Lawrence ang wala. Stop natin yung sharing.
No, continue talking, not the screen.
Ayan. Okay, dun muna tayo sa first. Sige. Wait lang po. Sige, hinintay lang po natin yung iba na mag-on.
Ito pwede natin gamitin doon sa students na slide. Kunyari nasa
Yup.
loob na kayo lahat.
Ayan. Sige. Ito lang tayo. Sige. Okay, 1, 2, 3. Okay, so next group naman. 1, 2, 3. Okay, yung iba hindi nakapag-on cam. Sige, that's fine. That's alright. Okay, again, maraming salamat sa lahat. And sana makita namin kayo sa Microlab, sa room 403. Alright?
Ang ganda
Thanks,
ng
everyone.
background ni Z. Ikaw ba yun? Yung nasa poster.
Si Ma'am.
Nasaan? Hindi ko nakita.
Kakambal ko po.
Magtanggal ka ng salamin, Mark, para makita mo.
Hindi, maliit eh. Hindi ko makita yung sa likod. Picture mo na lang, separate email mo na lang. Ilagay mo sa slide ng progress report.
Okay.
Oh, siya.
Again.
Bye, everyone.
Bye, everyone. Again,
Bye
maraming salamat po.
bye.
Everyone,
Bye.
bye-bye po.
Bye!
you.